Hello friends, welcome to Susan and John MathTube. This is the first lesson in multiple integrals, and my aim in this lesson is to make you understand the double integrals. Or rather, I want you to visualize what is happening in a double integral. And I have one more aim. I want you to understand how to extract the limits from graph. Okay. And one more very important thing, that is, before I start, I assume the students who are watching this video are good with basic integral or the single integral, because this is the next level, and only students who know the basic integration concepts will be able to follow me in this video. Anyway, let's start. And the first question is, what do you mean by a single integral or the integration which you have learned till now? Okay, integration stands for summation. So what is integration? Addition. So, okay, you might have thought about sigma. Well, sigma is also addition, but there is a huge difference between integral and sigma. In sigma, the plug-in values, if I write like let's say x equal to 1 to 5 and x stands for integers, then what happens is we plug in only the integer values. We will plug in only 1 square plus 2 square plus 3 square plus 4. At the same time, if I write x equal to 1 to 5, x square dx, then I am supposed to include all the output values starting from 1 to 5. Think about it. Can you list all the numbers between 1 and 5? No human being can do that. There are so many real numbers. I'm not talking about integers here. I'm talking about real numbers. Can you just even list all the real numbers between 1 and 5? Look at this. I'm asking just the real numbers between 1 and 5. It's an impossible job. But our integration techniques makes it possible. So the only difference between integral and sigma is discrete summation, jump summation, and integration stands for continuous summation. Okay, and geometrically, integration is actually the sum of all the heights. For example, I'll consider the function x square itself. So we have 0 square being 0, 1 square is 1, and 2 square is 4, and 3 square is somewhere far away 9. Anyway, look at this. Suppose I want to integrate from 1 to x square dx. What happens here is I add the first value, the next value, the next value, the next value. So that will create a lot of rectangles, small rectangles. And what I am doing here is I am adding the area of all such rectangles. And my friends, this is what you learned in the basic level. Okay, now we shift our focus and we start our double integration. Okay, now look at this. In single integration, there was only one input variable. In single integration, there is only one input variable, and here the input variable is x. And that means I am taking points from the real number system. In a double integral, there will be two input values, x and y. And of course, the function will be a multivariable function, f of xy dx dy. This will be the standard format of a multiple integral. And this actually implies I am taking the input values from two dimension. So in a double integral, I am taking my input values from a two dimension. Okay, now you have to understand one more thing. I have considered a region here, which you can see over here. And that region consists of many points. Look at this. There are so many points. I'll magnify that and show it to you. Look at this, it's made up of so many points. You can see those points, so many points. It's, no one can count that much number of points, crisscross here, there, etc. So basically it's made up of so many points, and every point in the two dimension will be in the format x comma y. Every point in the two dimension, if I consider this point, it will be in the form, of course, x comma y, maybe 1 comma 2, maybe 3 comma 4, maybe minus 1 comma minus 2. So remember, in a double integral there will be two input variables, x and y. That means the domain, the input region, is in two dimension, and every point in two dimension will be in the format x comma y. Is that clear? Okay, so in this lesson my major aim is to make you understand how to extract all the points and express those things as a limit. And for that purpose, I want you to consider x square plus y square is equal to a square. I am sure all of you know about x square plus y square equal to a square. It is a circle, and remember, whenever you talk about circles, you have to tell me two things. The circle will have center, origin, and radius a units. So look at this, we can draw this circle. Look at this, we have a circle with center, origin, and radius a units. So this is our center and this is our radius. Okay, now I want you to focus on the first quadrant. I want you to, let's say the domain, the input values are the first quadrant. So I'll make an example for you. Look at this, I want to evaluate this integral, double integral f of xy, and there is a region of integration, and the region of integration is the first quadrant of the circle. So the region I am interested is from here to here, and this is our circle, and of course this. So this is the region which I am interested in. You have to understand one very important thing. This region is made up of infinite number of points. There are so many points here. So you have to understand this region is made up of infinite number of points. Anyway, I cannot plot all the points, but still I am showing you. This will be the pattern of all the points. So look at this. This is the region of interest, and I think you can see the points. Now I want you to understand one thing. The points, if I consider in this manner, I am considering in a vertical perspective, the points vary from x equal to 0 to x equal to a. Here you can understand that the points are moving from x equal to 0 to x equal to a. I'll play it as an animation for you. Okay, look at this. I am considering the region first quadrant bounded by the circle. So here we have x equal to 0 and here we have x equal to a. Now my perspective is I am collecting the points in a vertical manner. So look, infinite number of points. I am writing only a few points. See, you can see so many points here. So there are infinite number of points aligned in a vertical manner. I am considering only in the vertical fashion. Oh, you can observe one more thing. The height keeps on decreasing. See, the height keeps on decreasing. I'll show it once more. I am collecting all the points. The height keeps on decreasing. And you can see that the points start from x equal to, if you look at the x-axis perspective, the points start from x equal to 0 and move towards x equal to a. At the same time, the height keeps on decreasing. Okay, so that is exactly what I want you to observe. And with this, we will be able to write the limit very easily. Clearly, x varies from 0 to a. That means I am considering all the points from, if you look at the bottom, I am considering from x equal to 0 to x equal to a. And now I told you the height is decreasing. So you can understand that the points, vertically, the points start from x-axis, because the boundary point is x-axis, and it ends at, look at this, every collection starts from x-axis and it ends at the circle. Every system, you can consider anywhere, it starts from the x-axis to the circle, from the x-axis to the circle, from the x-axis to the circle. So I am going to write y varies from x-axis to circle. Now x-axis means y is equal to 0 and circle means, okay, I have to extract that equation. It is x square plus y square equal to a square. So y square equal to a square minus x square. So y will be root under a square minus x square. Actually plus or minus, but we are in the first quadrant, so I can write a square minus x square. Okay, that's it, my friends. This is how we extract the limit from a given region. So I'll repeat once more, and this is the most important thing in double integrals. And I will give you the good news. If you understand this, you'll be literally be able to solve most of the problems with ease. What we do is we plug in these values in the integral. That is, we write x is equal to 0 to a. So remember, the constant limit will be written outside and the variable part will be written inside. That's it. And then one more thing, the differential of the inner one will be written first and then this. That means we'll be evaluating this one and then later the next one. Okay, I'll give you one more example and make it very clear. Okay, so we start with a line. So I'm going to take x by a plus y by b equal to 1. Okay, so we start with the line. And I want to evaluate the double integral over the region. How do you read this? Double integral over the region R and some function f of xy. Because in this video I am not bothered about the function, I am bothered only about the region. And my aim is to make you understand how to extract the limits from the graph. Okay, now this region is actually in the first quadrant and is bounded by the above line given a and b greater than 0. Okay, how many of you know this line? Yeah, I'm sure most of you have learned something called double intercept form. This is the equation of a line. It's very easy to notice the equation of a line because the degree of x and degree of y will be 1. So this is the equation of a line which will cut the x-axis at a comma 0 and the y-axis at b comma 0. So what's the specialty of this line? It will cut the x-axis at a comma 0 and the y-axis at b comma 0. So in other words, this point, this particular point is x equal to a and this particular point x equal to 0. Okay, now as always I'm going to magnify for your advantage. Now look at this. This is the required region. First quadrant bounded by the line, that means above the x-axis towards this side. Okay, now I want you to use a vertical perspective. Look at this. This region is made up of many points and I will not be able to draw all the points, but I am using a vertical perspective. Look at this. I am collecting the points in a vertical manner. I can collect the points like this also, but don't think in that manner for the time being. Let's collect all the points in the vertical manner. Okay, so are you able to see all the points? I put red dots. I cannot draw all the points, but I drew a lot of points. Okay, now I'll show you the animation. In the required region, we have many points aligned vertically. I'm looking at the vertical perspective. And you can see that the heights are decreasing. The height keeps on decreasing. And you can notice one more thing. X is moving from 0 to a. When you cover all the points, x moves from 0 to a. Right? Once more I'll show you. We start from x equal to 0 and move towards x equal to a. And the second thing I want you to notice is the height keeps on decreasing. Okay, that's it. So with this, I'll be able to write the limits. So I'm going to write x varies from 0 to a. And then I'm going to write y varies from. Can you tell me? Y is a variable. It's obvious because look at this. At every point, the height keeps on changing. The height here and the height here are different. So I'm going to write the height like this. Height means y values. Y varies from x-axis to the line. Isn't it? You look at any place corresponding to any x coordinate, the height will be from x-axis to line. Line means x by a plus y by b equal to 1. It's given in the question. Okay, now what is the x-axis? X-axis means y equal to 0. And what is the line? Line means we have to find the y value from here. Y by b equal to 1 minus x by a. So y will be b times 1 minus x by a. That's it. So we have the limits b into 1 minus x by a. Okay, we have to plug in the limits. So look at this. I'm going to plug in the constant limit first. And I can see that x has constant limit. X varies from 0 to a. And then I'll plug in the variable limits, the limit which contains the variable. 0 to b into 1 minus x by a. And f of xy. And to be honest, I should write dy dx. Because the inner limit belongs to y, so I put dy here. And when we evaluate, that will be in the next video, we will integrate with respect to y and then with respect to x. So I'm going to conclude this video now. But before that, I have to tell you something very important. Integration stands for continuous summation, continuous addition. Okay. In a single integral, there will be only one input variable. That means we take the domain values, the input values from the real number system. Whereas in double integration, there will be two inputs. And that means our input will come from the two-dimensional regions, two-dimensional domains. And two-dimensional domain will be made up of infinite number of points. In today's video, what I did is, I taught you how to consider the points in a vertically arranged fashion. I asked you to visualize the two-dimensional region to be made up of many points aligned in a vertical fashion. And from that, we learned how to evaluate the limits. Anyway, I'll be back with more in multiple integrals. So as always, if you like the video, please share, subscribe, like, etc. So we'll meet soon. So till then, my friends, bye.